Scientists unite, tourists of a Vengi in this
Math
fight.
scientist.
Together we are gone.
Hello and welcome to the tutorial on Numpy array, just library Numpy. So this is the first time we're going to import a library in the tutorial. And basically I'm going to explain basics of a library. A library is uh, basically a code that we can reuse that has been given to us by someone else. There is a collection of programmers who make libraries, then make them available to the common public. Especially in Python, it has a lot of libraries because it is open source. You can get a lot of libraries from the internet. I'm not going to show you how to get the libraries, but basically you have to do installations using the pip. I think I might make a video on that. But you have to do installations using the pip command. Okay, so what is NumPy? NumPy is basically a library that helps us with mathematical computations involving arrays, especially because arrays are very important in machine learning and in just general mathematics. Arrays are very important because they represent vectors, matrices, and sometimes tensors. So how do we make an array in NumPy? So the statement is very simple. All you have to do, let's give it a name and say out put np dot array. Then inside the parentheses you have to write basically a normal array, an array of floats, doubles, integers, whatever you, as long as they are numbers, make the array inside the parentheses. So for example, I'm going to say 2, 3, 4, and below this I'm going to say print out. You notice below here there is printed 2, 3, 4. That's what we wrote. So there are a couple of things we can do with np. Another thing we can do is make an array of zeros by using np dot zeros. Then you just write the dimensions of the array. Okay, right, 5. And that it will give us an array of zeros that is 5 in length. So it's just 5 zeros. This is the zeros function. Then there is the shape function. We can say let's say shape I equal to np dot shape, then putting out. So what we're doing here, this function will just return what the shape of the array is. Basically the shape here is 5 and 1, or just 5 and nothing basically, because it's just a 5 one-dimensional array. So we can say print out, and below it we can say print I. So I will represent the shape of the array. So it will give us 0, 0, 0, 0, then it will give us 5, which is basically how big the numpy array is. So we're going to go back to the function array. We're going to put an array now, parentheses. Then once I run this, see I'll get 2, 3, 4, and 3. So one other thing is just arrays are not necessarily just vectors. We can also represent matrices and tensors. And matrices and tensors, as I already said. So to represent a matrix in an array, you basically have to write a multi-dimensional array, which is basically an array of arrays. So instead of one bracket here, I can put 2, and I can put multiple arrays inside. For example, I can do 1. Then if I print this, find that this array is now 3 by 2. Now a 3 by 2 matrix in the, so it's 2 by 3. So this 2 by 3. That's what it's writing here. So another function I would like to represent, like to make known, basically you can, if we add to this, we want to make it a square matrix, is an n by n matrix. So we can add in values like this to make it a 3 by 3 matrix or a three-dimensional array. And we want to find the inverse of this array, this matrix. So to do this, we can say inverse equal to np dot linout dot inv. Then we'll put in the name of the matrix. So below it, want to print the inverse. So this is the matrix we put in here. This is the inverse of the. So those are just a couple of things you can do in Numpy. Let's deal with a couple of more. One of the things we can do, let's just use this. So instead of that, let's make a different array and write it second put np put array. I'm just going to copy the values in here. Okay. So the reason why I'm making a second one because we want to write how to add the arrays together. So we can say answer equal to np dot add out, and so with this function it will add all the numbers. So it will add 2 to 3 to 3, 4 to 4, 3 to 3, 2 to 1, and go on until it's done with it. Okay, so there was a slight mistake there. I had to fix that. There was an error coming up. It was just because of the parenthesis. I had put in the wrong parenthesis. But basically, when we run this, it gives us the sum of these two matrices. 2 added to 2, 3 added to 3, 4 added to 4, 3 added to 3, go on until it's done. So that's basically the add. And as you can imagine, the multiply, just multiply 2 by 2, 3 by 3, 4 by 4, 3 by 3. Now, a common misconception is that the multiply is going to do that, like how we actually multiply matrices like row by column. This will not do that. We just multiply individually 2 by 2, 3 by 3, and 4 by 4. As you can see, 2 by 2 is 4, 3 by 3 is 9, 4 by 4 is 16. That's what it's going to do. It's not going to multiply row by column. If we want to do that, we would have to use the dot. Now, this is the dot product. Now, the actual row by column model. This will give us. So those are just a couple of functions of things we can do with NumPy. So another important function that is usually used in NumPy is function called random. So random is going to generate a random array for us. So if we say np random dot and int means random integers, the answer is equal to this. You can just write the maximum number which it can generate when it's generating each random number. Then we can write the size equal to the size of the array. So we're printing. So as you can see, all these numbers are less than 10, and the numbers all in total are. So if we change this to 8, we'll get 8 numbers which are all